Good morning, Form 5. Today we are going to take Unit 1, Lesson 4, Operations on Numbers. We have 4 operations on numbers: addition, subtraction, multiplication, and division. This is the first part, which is addition. The addition, which is plus, has properties or has abilities. First, we are going to see how to represent addition on a number line, and then we are going to speak about the properties. When we see a number line like this, the first number is very important and the second number is very important. The order of the numbers, we can take it from here. How the first number is written, is drawn the first. Look, the first number is 2 centimeters or 2 units. How did I know? Because the first rectangle, it looks like a rectangle, is 2 units. So the first number is 2. And then he stopped here at 2. And then he continued in the same direction where it is getting greater, so it is plus. Plus from 2, how many units did he add, or how many centimeters did he add? 1, 2, 3, 4. So we had 2 plus 4, and the end he stopped at the result, which is 6. Number B. The first number or the first rectangle is 4 units or 4 centimeters, where he stopped at 4, so it is 4. When he continues in the same direction to get greater to the right, so that means it is plus. And the second number is 1, 2. He added 2 units or 2 centimeters to 4, so 4 plus 2, and he stopped on the result, which is 6. 2 plus 4, it is equal to 4 plus 2, but it differs on the number line. Number 2, we are going to speak about the properties of addition. Number 2, let's see the properties of addition. Addition has properties, and I'm going to write them on the board now so we can solve. The first property, it is called the closure property. What is the meaning of closure property? Closure property means that if you have any 2 natural numbers, only natural numbers, no decimals, no negative, and you are going to add them, before we calculate the answer, if these 2 numbers that you are adding is natural, so the answer will be a natural number also. So that means that addition of natural numbers is always possible. That means if he brings for you like this, a plus b, and asks you to put element belong or element doesn't belong, we are going to put element belong. Whatever the number a and whatever the number b, if a and b are natural and you are adding, so adding natural numbers will always be a natural numbers. There is no other solution. So this is called the closure property. The second property, it is the commutative property. What is the meaning of commutative property? Commutative property means if you have 2 numbers and you are adding them. Example, 3 plus 2. Is it equal to 2 plus 3? Is the addition has the ability to exchange the places of the numbers? The ability of exchanging the places of the numbers is called commutative property. So yes, 3 plus 2 is equal to 2 plus 3. So this is an ability in addition. Maybe it's not there in subtraction, for example, and it's not there in division. So this is an ability in addition, and it is called the commutative property. The third property is called the associative property. The associative property. What is the meaning of the associative property? The associative property is when you have more than 2 numbers. For example, 3 plus 2 plus 1. And then one of you likes to solve or group 3 plus 2 first, like this, to solve them together. And then the answer of this brackets, he is going to solve it with 1. Is this equal to this and equal to another one who likes to group 2 plus 1 to solve them the first, and its answer he will solve it with 3? Is all of this equal? Is it possible to group any 2 numbers together if you are adding? Let's see. If the 3 answers are equal, so that means that the addition has the associative property, has the ability to leave you group any two numbers together. This will not affect the answer, okay? Let's see. 3 plus 2 plus 1 is equal to 6. This is 6. Let's see. 3 plus 2 is equal to 5. And 5 plus 1 is equal to 6. So it's the same. And here, when we put brackets on two numbers, that means that we are going to solve them first. Let's solve the brackets first. 3 plus 3. It will also be equal to 6. So that means that the operation that you are using, which is plus, has the associative property. We say it, addition is associative. Means it can leave you group any two numbers together. But we want to speak about associative property. As you see here in this line, that the number stays in its places. Number 3 is the first, number 2 is the second, and number 1 is the third before the equal. And after the equal, they are still in their places. 3 is the first, 2 is the second, and 1 is the third. Who is really moving in the associative property is the brackets, because we are grouping any two numbers together. Okay? So addition is commutative and addition is associative. There is a fourth property in addition, and it is called the additive identity. The additive identity property. The additive identity property means that there is a neutral element in addition. It is called the additive neutral element. What is the meaning of this and this? The additive neutral element means the element which is the number that is neutral, has no color, means has no effect in addition. So these words are very important. In addition, the number that has no color or no effect in addition. There is an additive neutral element which is 0. Why? Because in addition, if I will take any number and then in addition add a 0 to it, it will be the same as 0 plus 7, and at the end the answer will stay 7, as if we didn't do anything in the problem and 7 stayed 7. That means that the number, the element that is neutral in addition is 0. And this was the last property. To solve the exercise, we must take care and look at the problem to know what is the property that he used. Now we are going to solve number 1. Look here, 12 plus 5 equal 5 plus what? What happened here? 12 was the first number and 5 was the second number. After the equal, 5 became the first number. So of course 12 will be the second number. When 12 becomes the second number, that means when 12 becomes the second number, that means that what did he do? What did he do? He exchanged places, which is called the commutative property. Number B, 7 plus what will give me 7? What is the number? If I add to 7, it will not affect it at all. It is 0. And when you add by 0, you are doing nothing, and it is called the additive identity property. Number C, brackets 5 plus 3 plus what is equal to what? Plus brackets having something plus 2. The only brackets that we took is the associative property till now. And as we see, the brackets is moving. It was between the first two numbers before the equal, and after the equal it's between the second two numbers. So till now it is easy because we didn't take any brackets. So to bring this number or this number or this number, what shall I do? As we said in associative property, the first number before the equal will be the first number after the equal, and the second before the equal will be the second after the equal, and the third before the equal will be the third after the equal. So we are going to bring this from here and this from here. The third number here before the equal is 2. And the first number after the equal is from here 5. And the second number, we are going to bring it from before the equal, it is 3. And this is the associative property. Number 3, the additive neutral element in n, the number that has no color or has no effect in addition is 0. Number E, A plus B. Put element belong or element doesn't belong. If you are adding A and B, where A and B are natural numbers, so before you calculate the answer, you know that the answer of addition of natural numbers will always be an element belongs to n, meaning it cannot be decimal and it cannot be fraction as long as we are adding and as long as these two numbers are natural. Number 3, we want to know, we knew that addition has properties. If you have a property, if you can play football, you will go and play football. You will use these abilities. Now, after we knew that addition has abilities, let's use them. Number 3, use the commutative and associative properties to simplify and solve these problems. How to simplify a problem? When we use the commutative and associative properties to simplify, in addition, to simplify, we must create more zeros. We must look for the friends that give us more zeros in addition. This is the meaning of using commutative and associative. Look for the numbers that will give me more zeros, which are the units of a number plus another units of a number that will give me 10, because 10 has 1 0. So it is 1 plus 9 as units that will give me 10, 2 plus 8, 3 plus 7, 4 plus 6, and 5 plus 5. In the problem, he will take care to bring these numbers. Okay, number 1, please identify the units. 9 and 7 and 1. And then 9 plus which unit, take care of the operation, will give me 10. Yes, it's 9 plus 1. So this number became a friend to this number. And then it is solved in 4 lines. 1, 2, 3, 4, where each of these 4 lines are equal to this problem. What we are going to do now, we are going to use the commutative and associative to create more zeros to simplify this problem. The first step is to use the commutative property, where we are going to exchange the places of the numbers to bring the numbers that will give me more zeros beside each other. We will bring 1 beside 999 and then put 487 at the end, and this is called the commutative property, where we exchanged places of the numbers. The second step, or the second line, is to put brackets on the friends that will give me more zeros and write the number that doesn't have a friend alone. Once we grouped 2 numbers together or put brackets, this is called the associative property. The third line, we are going to solve what's in the brackets first, because when I put 2 numbers in a bracket instead of 3, that means I'm going to solve them first. So the third line, we are going to solve this on the calculator. It will give me 1000, and then don't forget to take these down. Like this, look. This is equal to this, equal to this, equal to this. Like this, it needs time to solve. But when we created more zeros, I can solve this without calculator. It will be 1487. This is the meaning of using commutative and associative properties to simplify, then solve. I simplify to more zeros by adding, and then I can add without calculator. So it is 1487 at the end, which I knew from the beginning that this will belong to n, all of this, because I'm dealing with natural numbers, and I write closure property. This is how we use the commutative and associative to simplify and solve. Number B, the same. I need to simplify, so I'm searching for the units plus units that will give me 10. 5 plus 5, so these are friends. And 2 plus 8, so these also are friends. Let's start our 4 lines. 45, bring its friend beside it, and then write 82, and then bring its friend beside it. Like this, I exchange the places of the numbers, which we said it is called commutative property. The second line is to write them as they are and put brackets on the friends. Group the friends between brackets. When we put brackets or group, it is called associative property, because we put brackets on what we see that are friends, on anyone. The third line, as we said, we are going to solve what's in the brackets, and what's outside will go down as it is. 45 plus 55 on the calculator, it is 100. Plus goes down. 82 plus 18 is also 100. Look, the problem became 100 plus 100, and they are all equal. I couldn't, or I need time to solve this when I see it, or I need a calculator. But at the end, 100 plus 100 is so easy, I can solve all of the problem to be 200 without calculator. This is the meaning of using commutative and associative, in addition to create more zeros, so you can solve a problem, which I knew from the beginning it will be belongs to n. This I must write it, and then closure property. Thank you, Form 5, for watching. Wait for the second part, which is subtraction. Bye-bye. Hi, Form 5. Now we are going to take the second part, or the second operation in natural numbers, which is subtraction. First, the number line. We look at the first number started from 0, and it is from up. The first number, which is the first rectangle, is, as we said, 5. Because the first rectangle is 5 units or 5 centimeters, and it's from up. And then, from 5, I didn't go forward, so I didn't go to the right, so I didn't go greater. We went to the left. We went to the left, that means that 5, it is going to get smaller, so it is minus. And then, from 5, I moved to the left, or backwards 2 units, so it's 5 minus 2, which is at the end, will stop at 3. So it is easy. This is 5 minus 2 equal 3. In number 2, the first number is the rectangle from up, which is 4. And then I didn't continue after 4 to get greater. I went in the opposite direction, which is left, to go smaller, so it is minus. 4 minus 1, 2, 3, which will give me the answer where he stopped from down, which is 1. It is easy. In subtraction, subtraction is not closed. Natural numbers is not closed under subtraction, because once I can use, for example, 5 minus 2, both of them are natural. Sometimes it will give me a natural number which belongs to n, but I can use, for example, 7 minus 9. On the calculator, let's see, will this belongs to n? Although 7 is a natural number and 9 is a natural number, but on the calculator it will give me something called negative 2. Negative 2 is less than 0, and the first natural number we have is 0. So negative numbers doesn't belong to n. What I'm saying here, that subtraction of natural numbers, once it can give me a natural number and once not, it gives me negative. So to say that this belongs to n, or natural numbers must be closed, the answer must always be a natural number. It can be two things. It can be once a natural and once not. So here we say it is not closed. There is other solutions, okay? And it is not commutative, because 5 minus 2, it will not be equal to 2 minus 5, because 2 minus 5 will give me negative 3. Look, from 5, if you start the subtraction by the smaller number, it will give you negative, okay? So it is not commutative, and it is not associative, and it has no identity property because it has no neutral element. All what we have in subtraction is these number lines, and put element belong and element doesn't belong. Number A, as it is on the calculator, 0 minus 7, as we said, if you started the subtraction by the smaller number, the answer will be negative. But you can do it by the calculator, and the calculator will give you negative 7. Negative 7 doesn't belong to n. Number B, as it is, with its brackets, with everything on the calculator, it will be 7 times 3, 21, minus, it will be 14. It will be 14. I think so. So this will be belongs to n. Number C, as it is, it will give me 0. So 0 belongs to n. Number D, if you have A and B natural numbers, if you are subtracting them, is the answer it will be belongs to n? No, not always. It is not always possible, so it doesn't belong. Number E, 45 minus 35, it will be 10. So 10 belongs to natural numbers. So what we knew now, that if you are subtracting and the answer is negative, so this doesn't belong to n. Thank you, Form 5, for watching, and wait for part 3 multiplication. Bye-bye.